On to word problems. Okay, so the word problems, we're just plugging in values and then solving for a variable. So this first one we have, biologists have discovered that the shoulder height h, so we want to keep these in mind, shoulder height h. Here, I'm going to highlight it. That's why I have a highlighter here. So the shoulder height h in centimeters of a male African elephant can be modeled by this equation. So we're given the equation where t is the age in years of the elephant. Determine the age of an elephant. So here we're trying to determine the age. So that's going to be our unknown. Determine the age of the elephant whose shoulder height, so we're given the shoulder height, is 200 centimeters. Round your answer to the nearest year. So we're going to use this formula, and we're given the shoulder height of 200. So shoulder height is h. So I'm going to plug 200 in for h. So this will be 200 equals. And then we have 62.5, the third root, and t is what we're trying to find, determine the age. So t is the age in years, so that's why it stays as t, plus 75.8. Okay, so to solve this, I'm trying to solve for t, so I'm going to get all this stuff rounded away. So I'll first subtract 75.8. Okay, so 200 minus 75.8 is 124.2. 62.5, third root t. Now I can't cube both sides yet because I have the 62.5. So I would divide it out because it's 62.5 times the cubed root of t. So I divide it out to get rid of it. So I have 124.2 divided by 62.5. 1.9872. Okay, so I'm going to write cubed root of t, because that's what I have. And I'm just flipping which side it's on. I just prefer my variables on the left. This is equal to about 1.9872, and now cube it. And that cancels out the radical. I'm left with t equals, and in the calculator, if I just hit the caret key at this point, it will take the previous answer and I raise it to the third power to get 7.8, I'll round to there, 7.85. So this says round your answer to the nearest year. So just writing t equals something is not giving me an answer. What I want to see is the year, so determine the age. So the elephant would be about 8 years old. This is how you properly answer a word problem with a sentence. Okay, next one. The Beaufort wind scale was devised to measure wind speed. The Beaufort numbers B, which range from 0 to 12, can be modeled by this guy, where the speed of the wind, where S is the speed of the wind. So here we have S is the speed of the wind. And we're finding the wind speed when the Beaufort number B equals 11. So we're just trying to find the wind speed. So I'm going to plug 11 in for B. So 11 equals 1.69 square root S. So that's what we're trying to find, is the wind speed, S, plus 4.45 minus 3.49. Okay, so again, solving for this S, I'm going to first get this stuff rounded away. I'm going to add 3.49 to both sides. 11 plus 3.49 is 14.49. 1.69 square root S plus 4.45. and I need to get rid of this number in front of the radical first. So I divide it out, 0.69, 1.69. So here it cancels. 14.49 divided by 1.69 would be about that. So I have 8.574, so I'm going to round it to that, equals square root of s plus 4.45. So it's okay I rounded it here, but I'm keeping it in my calculator so that when I square it, I have an even more accurate number in my calculator. So, because we have to square it to get rid of the radical now. So this, I'm going to take the answer squared to get 73.513 equals s plus 4.45, and then subtract the 4.45. So minus 4.45 is 69.063 equals s. So it's saying find the wind speed that corresponds, and this is in miles per hour. So I will write the wind speed is about 69 miles per hour. And there's that answer. All right, so number 24. The length L in inches is modeled by this equation. So we have the length L in inches of a standard nail. So we're talking about nails. Is modeled by this equation where D is the diameter in inches of the nail. We'll include in inches. What is the diameter? So it's asking what is the diameter, which means D will be our unknown, of a standard nail that is 3 inches long. Okay, so we're given a length and we're finding the diameter. So we're going to plug 3 in for L. So this will be 3 equals 54D to the 3 over 2. Alright, so from here, what I can do, notice how this is in parentheses to the 3 over 2, which means 54 is not raised to 3 over 2 power. So I can divide out that 54 first. We can reduce this fraction. 3 goes into 54, 1 over 18. So this would be 1 over 18 equals D to the 3 over 2. And now I'm going to do the reciprocal of this exponent. So 3 over 2 reciprocal is 2 over 3 and 2 over 3. So here my exponents cancel out. I'm left with D equals, and 18 to the 2/3, so I'm going to write this as a radical. This is the third root of 1 over 18 raised to the second power. So let's use the calculator here. Third root of 1 over 18, and I'm going to raise it to the second power. And that's what we get. So the diameter, D, equals 0.145. So given the diameter, what is the diameter of a nail? So the diameter is 0.145 inches. Okay. All right. So next one, number 25. Scientists have found that the body mass in kilograms, body mass M, here's a variable, of a dinosaur that walked on 2 feet can be modeled by that, where C is the circumference in millimeters of the dinosaur's femur. scientists have estimated that a mass of a Tyrannosaurus rex might have been 450 kilograms. So if that's the mass of the body mass of a T-Rex, so that would be our M. What size femur? So what size femur would have led them to this conclusion? Okay, so we're looking for the size of the femur. That's our unknown. Okay, so 4,500 is what we're plugging in for M, equals 1.6 times 10 to the negative 4 C to the 273 over, oof, that's hefty. Alright, so first I'm gonna, so when it's number times 10 to the negative 4, that means how many decimal places we have. So this would be over 4 decimal places. I'm going to divide this out first. So 1.6 10 to the negative 4. And divide this. So let's just actually calculate that. 1.6 times 10 to the negative 4. That would be 1 over 10 to the 4th, which would be over, this would be 16, 1.6 divided by, so remember negative exponent rule, 1.6, and then this has a negative exponent, so it's 10 to the 4th. So I'm going to do 1.6 divided by 10 to the 4th, and this is what we get, that fun number. Yeah, this one isn't fun. So what I'm going to do is, I'm going to keep it like this. So remember, when you divide by a fraction, you multiply by the reciprocal. Okay, so I'm going to divide 4,500 by 1.6. So 4,500 divided by 1.6 is 2,812.5 times, and then this will be 10 to the 4th, equals C to the 273 over 100, and then we multiply by the reciprocal of that exponent. So it's 100 over 273. 100 over 273. Honestly, you could just leave it like that. Yeah. Okay, next one. Last one. The formula. S equals 2 pi square root of L over 32. S is the time in seconds to swing back and forth on a pendulum, and L is the length of the pendulum in feet. How long does it take for a 3-foot pendulum? So we're given the number of feet, and we're asking how long. So that would be the time in seconds. That's what we're trying to find. So we have S, so that's our time in seconds, our unknown, equals 2 pi square root. The length in feet, we have 3 over 32. And you could leave it like that. That would be the most accurate way to represent it. If we want to estimate, though, the amount of time, I mean, nobody would know, like, oh, in 2 pi square root of 3 over 32 seconds, it's going to swing. So let's put this in terms of reality here. So S equals 2 times pi times the square root of 3 over 32. And that's what we get, 1.9. So I'm going to put a little dot over that. So it's estimating 1.924. So on here, how long does it take? It takes about 2 seconds. And that would be our answer. Right. Okay, so that's it for word problems.